Hi guys, this is Mrs. Lyons. Today we are going to talk about single replacement reactions. Single replacement reactions take place, as you can see here, the generic equation. We have a compound, AB, and an element as our reactants. And what happens is the element takes the place of one of the compounds in one of the elements in the compounds, and we form a new compound, and then a different element is by itself. Okay, and it's important to note that our generic equation could take two forms, because the element will take the place of one or the other of the elements in the compound. So in this case, C takes the place of A. Okay, so we could have it work either way, but we always start out with a compound and an element. We always end up with a compound and an element. It's just that one of the elements has taken the place of the other. Sometimes we represent this with people. We say that Mary and Frank were a couple, and then Joe comes along, and Mary likes Joe better, so now Joe took Frank's place. So Joe and Mary are together, and Frank is by himself. So think about this. We've got A plus B, C, so we've got an element plus a compound, and what happens is we end up with AC plus B. So it's a single replacement reaction. This is just representing it with people. Same thing we did with our Shall We Dance. Here we have A, guy B with girl C. Okay, I paused there. Let's see, where was I? Guy A cuts in on couple BC. And what happens is then A takes B's place, and we end up with B all by himself and couple AC. Okay, so when you think about single replacement, think about a single person taking someone else's place in a couple. All right, so let's look at this. There's one thing that we have to look at when we are looking at single replacement reactions, and that is, why would girl C choose guy A over guy B? Okay, and we have to look at this in terms of chemicals. And with our elements, we have something called the activity series. And with this activity series, what this tells us is which element is most reactive. And I have you, when we're thinking about the dating thing, think about which element is most attractive. Because the most attractive element is going to be the one that ends up in the couple. Okay, so this list shows us, and notice there's a couple of nonmetals in here, carbon and hydrogen, because sometimes carbon and hydrogen are involved in single replacement reactions. Okay, so the way this works is the most reactive element wants to be in a compound, or gets to be in the compound. Okay, because it's reactive, it doesn't want to be, it's not stable when it's by itself. Okay, so the most reactive element is in the compound, in the products. Okay, and that's because it's reactive, it's unstable. By being with another element, it becomes more stable. Okay, so let's look at this example. If I have sodium metal plus a compound, silver chloride. Okay, now the first thing is to figure out which elements would replace which other elements. So we have to think about metals and nonmetals. Okay, sodium is a metal, silver is a metal, chlorine is a nonmetal. And if you notice, sodium and silver are both on our activity series list. Here's sodium, silver's all the way down here. So sodium and silver are the two elements we're going to combine. Okay, now sodium is by itself. The question you have to ask is the element, okay, so the thing by itself, more reactive than the metal in the compound? Okay, so in other words, is sodium more reactive than silver? So we look at our list, sodium is way up here on our list, silver's way down here. So sodium is more reactive. So what's going to happen here is sodium is going to go and it's going to want to dance with chlorine, and it's going to kick silver out. So our products, we're going to end up with silver by itself, and then we're going to end up with a compound that's made up of NaCl. Now, if it's just an element by itself, it's only one of them unless it's one of the Hobart-Finkel 7. If it's a compound, we have to think about charges. Sodium's +1, chlorine is -1, so this ends up being sodium chloride. So our balanced chemical equation is Na plus AgL yields Ag plus NaCl. So these are our products, are right here. Okay, so let's do another example. So let's say we have magnesium plus sodium fluoride. Okay, again, we have to look, we have to compare what two things are on our list. Okay, if we look, magnesium is here, sodium is here. Fluorine's nowhere to be found on this list. So the two things that we're going to combine, or we're going to compare, are magnesium and sodium. Again, we want to ask ourselves, is the element more reactive? In this case, so is magnesium more reactive than sodium? Magnesium's below sodium, so the answer here is no. Magnesium is not more reactive. So magnesium may come in here and try to take sodium's place, but sodium says, no way, dude, I'm hotter, I'm more attractive, fluorine's going to stay with me, you can just go back and go home by yourself. Okay? That's what's going to happen. So how do we write that? Our products stay the same. There is no reaction. So that's what we're going to write. No reaction. We can abbreviate because we know that we always want to do as little writing as possible. We can say NR, no reaction. Okay, so we don't have products. We write NR. Guess what? We don't have to balance that equation. We don't have to predict the products. It doesn't happen. Okay, so sometimes in single replacement reactions, the reaction just doesn't take place. Let's look at something else we have to think about. Okay, in all of those cases, we were comparing metals. There's also a chance with single replacement that we might replace the nonmetal. So, and when we do that, we're talking about the halogens. So group 17 elements, fluorine, chlorine, bromine, and iodine. Okay, and we have a list here. Fluorine's most reactive, then chlorine, bromine. Iodine is the least reactive. So when we look at this type of reaction, now we're going to look. We have fluorine plus magnesium chloride. Okay, if you looked at that other list, only magnesium is on the metals list. Fluorine and chlorine are both on our halogens list. Fluorine and chlorine. So we have to ask ourselves, is the element more reactive than the halogen in the compound? Is fluorine above chlorine? In this case it is. So fluorine is going to come in, it's going to kick chlorine to the curb. So our products, chlorine is going to end up by itself. Remember, chlorine is a Hobrofinkel, so we've got to have Cl2. And then fluorine moves in. So we're going to have magnesium and fluorine forming a compound. Magnesium is +2 on the periodic table. Fluorine is -1, so we end up with MgF2. Okay, so fluorine plus magnesium chloride, the products are chlorine and magnesium fluoride because fluorine is more reactive. Fluorine wants to end up in the compound. Let's do another example with a halogen. In this case, we've got bromine plus sodium chloride. So the two halogens we're looking at are bromine and chlorine. We want to ask ourselves, is the element, so is bromine more active than chlorine, more reactive? The answer is no, because chlorine is higher up. So bromine's going to come in and try to kick out chlorine. Chlorine's going to say, no way, man. I'm more reactive, I'm more attractive, I want to be with this sodium more. You don't have a chance. So chlorine's going to hold on to the sodium, bromine is going to just have to go away. What we say in this case is NR, no reaction, because bromine is not strong enough to take chlorine's place. It's not reactive enough. Okay, so that is a look at single replacement reactions and how we predict the products of single replacement reactions. I hope this helps, and I will see you in class.